My name is Chanel.
I'm Amora.
I'm Russell.
And we are doing confidence intervals and margin of error.
First, we're going to start off with confidence intervals.
Okay.
Okay, so first we're going to start off with confidence intervals. A confidence interval is an interval calculated from the data, usually of the form, estimate plus or minus the margin of error. A confidence level C gives the probability that the interval will capture the true parameter value in repeated samples. The confidence interval formula is x bar plus or minus z star times the standard deviation over the square root of n. X bar is the sample mean. Z star is the percentage of the confidence interval we wish to find. We can find this in table C. The standard deviation is the standard deviation of the entire population, while n is the number of units in the simple random sample. Let's look at an example.
A manufacturer of high-resolution video terminals must control the tension on the mesh of fine wires that lies behind the surface of the viewing screen. Too much tension will tear the mesh, and too little will allow wrinkles. The tension is measured by an electrical device with output readings in millivolts, or MV. Some variation is inherent in the production process. Careful study has shown that when the process is operating properly, the standard deviation of the tension readings is standard deviation equals 43 MV. Here are the tension readings from an SRS of 20 screens from a single day's production. Construct a 90% confidence interval for the mean tension mu of all screens produced on this day.
So let's start off with step 1. Step 1 is to identify the population of interest and the parameter you want to draw the conclusion about. The population of interest is all the video terminals produced on the day in question. We want to estimate mu, the mean tension for all the screens. Step 2 is to choose the appropriate inference procedure. Verify the conditions for using the selected procedure. Since we know standard deviation, we should use the confidence interval for a population mean that was just introduced to estimate mu. Now we must check the two required conditions. 1. The SRS from the population of interest, and 2. Sampling distribution of x bar approximately normal are met. We know this because the data came from an SRS of 20 screens from the population of all screens produced that day. We know that the x bar is approximately normal because past experience suggests that the tension readings of screens produced on a single day follow a normal distribution quite closely. If the population distribution is normal, the sampling distribution, x bar, will be normal. Let's figure out x bar. The mean can be figured out by adding up all the values given to us in the SRS and divided by the sum of the total number n. When we do this, we get 306.32.
There's also an easy way to do this by putting in all values from the simple random sample in list 1. Then press stat on your calculator. Go right once to get on calc and press enter on 1var stats. Then enter list 1 on your screen and press enter. This will also get you the mean.
Now let's find z star. To find z star, we look in the back of the book at table C. When we get there, we look at the left column, degrees of freedom, and go down to z star. Then we look at the bottom of the page at the percentages and find 90%. We see that z star is 1.645. We were given standard deviation and n, so all we do is plug those numbers in and solve. Remember, we must plus and minus the mean from the margin of error. We finally get 290.5 and 322.1 as our answer. Now we must interpret the steps in step 4. We are 90% confident that the true mean tension in the entire batch of video terminals produced that day is between 209.5 and 322.1.
The next one is margin of error.
Margin of error is the statistic representing random sampling error in a survey's result. The equation for margin of error is z star, standard deviation divided by the square root of n.
Let's try an example. Company management wants a report of the mean screen tension for the day's production accurate to within plus or minus 5 MV with 95% confidence. How large a sample of video monitors must be measured to comply?
Alright, to find what you're looking for, you need M equals 5. Z star is equal 95%. To find this, you have to go to table C, which will equal to 1.96. The standard deviation, which is given to you in the equation, equals 43, and the square root of n is what you're trying to look for. So, to put this in the equation, it's going to be 1.96, 43 divided by the square root of n, less than equal to 5. To find the square root of n is greater than or equal to 1.96 times 43 divided by 5. Now your answer will be square root of n greater than or equal to 16.856. Now you have to square both sides of the equation, and it's going to be n greater than or equal to 284.125. Now, anytime you have a decimal, you want to round up. So your final answer will be 285.
That's it!
Okay.